Okay, great stuff. So this next set of questions are the last questions in this this short sort of, when I say series, just the everything we've been talking about till environmental accounting, because we were looking at chapter 1 to 4 in our text. So we're just going to do those, the rest of those questions, and why not? Let's work through them. So 63 to 65, and then we'll do 66 to the end. So what do we have? I mean, environmental accounting in class, if you remember what I was trying to highlight, really what they're trying to get you to do here is to recognize the importance of environmental costs and really the EMAs, the environmental management accounting methods, really. So flow accounting and input output accounting, please read up on those. There's nothing really to them. Input output, what goes in should be what comes out, find the difference, or why is there a difference, as opposed to flow accounting is really based on the components of things at the different stages. So you have your materials, you sort of your input, so to speak, and then you have your delivery and system costs, and then you have your disposal costs at the end. So it's just classifying them, and if we can classify them, we know what they are, we can then drive them and whatever. And then we have activity-based sort of methods as well. So if we can know what's causing them, then we can manage them. So let's look at this question. You have a scenario. This is an input method, sort of this input-output method. So it's almost like process costing. So you have with process costing, you have T accounts, and you have losses. So you have a scenario where you're pouring in 1,000 kilograms into this thing. That's the cost of 50,000. Then you have some more costs of labor and utilities and overheads. So you have a total cost of 80,000 that's gone in. And then what comes out, expected output, is 70% of input and can be sold for 120. So we have there some contribution towards revenue. Expected waste is 10% of input. So really, well, we have 10% of input, and expected scrap is 20% of input. So these are why we don't have 100 pure kilograms coming out. But we have some waste, which is normal, byproduct, or whatever it is, of 10% of input, and that comes to 1,000. And then you have expected scrap of 20%, so 70 plus 10 plus 20 make 100. Scrap of 20% of input, and this can be sold for 15. So we can still make something of this one here, which is why this adds on to our income. So we now have 86,000. Compare the two, so it's currently 66,000. 6,000. So monthly profit is expected to be 6,000. But then there's a movement. It says the company is looking to introduce new quality systems that will increase sales costs by 5,000. So I'm now going to do something here where I increase this by 5,000. That's what's going to happen. And what I'm also going to do is I'm going to reduce waste from 10% to 4% here. And scrap is expected to stay at 20% input. So if this is going to stay the same at 20% input, and I'm going to reduce this to 4%, to get my total 100%, it means that my expected output has somewhat increased by 6%. So ultimately, I have a scenario here where I now have 760, I have 40, and really what I want to be doing is 760 times 120 less 400, and this has stayed the same of 3,000. So that's the new method, or that's the new picture that I have with me now. So 760 times 120 is 91,200. And then, so yes, I have that in terms of my output. And then I have less 400. So I just need to recalculate basically what's going on. So now I have a total cost of 85 grand. And what I have as well is, if you like, new profits of, or if you like, outputs of 91,200 less the 400 plus the 3,000. And that's 93,800. Have I got that right? Let me just check my calculations. 93,800. That's correct. So 93,800. Good. So now I notice that my new profits are 93,800 minus 85,000, which is 8,800. And the question asks me, what is my what will be the impact on on monthly profit, and I see that I had 6,000 before, now I have 8,800, so it means that you're going to have an increase in profit of 2,800. So your answer becomes D. Good. So just watching it carefully, I think this is the bit that people can slip up. We need to account for the full 100%. We need to know what's waste, we need to know what's expected output, what's good output. So we have that. Okay, different management technique can be used. One of the methods analyzes in 3 different categories: material, system, and delivery and disposal. I talked about this. This is referred to as the flow accounting cost accounting method. I guess it's a knowledge thing. You just have to know it. So it's called the flow cost because we break things up, like I said, into, it's almost like I have a diagram somewhere that has something that looks like that, if you like. So you kind of know what materials are going in, and then it's going through a series of systems costs, until it ends up being a case of delivery and disposal, and having a way of tracking things as you're going. So the answer there is D. Yes. Right, so let's look at this, 65. Which 2 of the following about the advantages of A, B, C for environmental MEMA are correct? Well, if you can trap the environmental costs, you could pass on the prices. That's quite normal. So typically the problem is if you can't capture the cost, it's very difficult to integrate that into your pricing. And definitely cost savings achieved through environmental policies can be measured. It is never simple determining environmental costs and therefore the drivers. And you just can't consider, there's so many effects that the company has that it'll be difficult to consider all. I think these are what's giving it away, the fact that it says all, and the fact that here it says it is simple. It isn't simple. So these, unfortunately, these 2 fall out. They're not correct. So the answers are the first one and the second one. And that's 65. Cool, great stuff. I think that's a good place to stop, and we'll do the last couple of questions in the next video.